All right, everybody, here we go. 11.2 properties of tangents coming your way. A little bit of calculations today. I hope you're excited because I am. Here we go. First thing I want you to do is write these two theorems down. I want you to write the theorems, the hypothesis, and the conclusion. So write these down, pause it, and I will let you know what we're talking about. All right, so the first one says, if a line is a tangent to a circle, then it is perpendicular to the radius. So if I look at this very top one, AB is my radius because L is tangent to A. This means that this has to be a 90-degree angle because it's perpendicular. Okay, if you go the opposite way, if a line is perpendicular to a radius of a circle, at a point on the circle, at one point on the circle, then you can say that line is a tangent. So at the bottom one, line M is perpendicular to radius CD. Because of that, M and CD have to be perpendicular, and that predicts or says that or concludes that M is a tangent to C. All right, two very quick theorems. There you go. Now let's work with them a little bit. Here we go. Very first one you do not have to write down. You just have to enjoy this beautiful drawing we have here. It says in wonderful handwriting, AB is tangent to circle C. We are finding X. So if I look at this, I have my triangle. Notice there's a triangle A, B, and C. Notice I know a few measurements and I want to find X. I want you to try to think of a way. How in the world do you think I would find X? Okay, I'll give you a hint. Notice, remember, our theorem said that if a line, okay, if we know that AB is tangent, we can see that AC is a radius. If we have a tangent line that touches point or circle C, and CA is going to be your radius, we know that that's a 90-degree angle. Now I'll come up with a way to find X. Did you do it? Let's find out. We would do x squared plus 20 squared is equal to 25 squared. What am I doing? Pythagorean theorem! Pythagorean theorem! It comes back! Yeehaw! Woohoo! Excited, excited. So when I take this, I take 20 squared, I take 25 squared. I end up with x squared plus 400 is equal to 625. I am going to subtract 400 from both sides, minus 400, not 140, 400, and I get x squared is equal to 225. Now, I have 225, I have x squared. How do I undo a squaring symbol? Well, we need to take square root. How could you ask that, Mr. Sheeman? You're so weird. Your answer is 15. 15 is going to be that length of x, or x is 15. All right, so we use Pythagorean theorem because we had this 90-degree angle, or 90-degree triangle, or a right triangle, and we want to figure out what x is. All right, so that's what you do. Give the next one a shot. Looking at this beautiful drawing here, these wonderful colors, I want you to find X in this situation. Go ahead. All right, so when you did this, I know you did this correctly because you plugged it into your Pythagorean theorem because you guys are so good. You take x squared plus 4 squared is equal to 5 squared. We know that 4 squared is 16. We know that 5 squared is 25. We're going to subtract 16 on both sides. I am moving very fast because this is all good math. We take the square root of 9 and we get x is equal to 3. It's a 3, 4, 5 triangle. That's a special triangle. It's a Pythagorean triple. Yeah. Okay, x is equal to 3. Plug it into our Pythagorean theorem. We square everything and we come back and we answer. All right? Awesome. One you are going to do is another theorem. It says if two segments are tangents, remember tangents of the same circle, to a circle from the same external point. So point A here is an external point, a point not on the circle, not internal, it's external. Okay, then the segments are congruent. So AB and AC have to be congruent because they come from the exact same external point. Okay, so finish writing this down. If you need to, I'm going to move on in a 5, 4, 3, 2, 1. Moving on, so pause if you didn't write that. Okay, here we go. HK and HG are tangent to circle. That's not a square. That is a circle F. You're going to find HG, not HGTV. HGTV. Oh, man, that's funny. You are finding HG. So, based on that last theorem that you just wrote down, how would you find HG? Well, notice they come both from the exact same external point of H. So because of that, what can I do to those equations, or those two expressions? Set them equal to each other. And you get 4 plus 2a is equal to 5a minus 32. I'm going to combine everything I can combine. Subtract 2a from both sides. I get 4 is equal to 3a minus 32. I'm going to add 32 to both sides. And I get 36 is equal to 3a. How do you come up with a? Divide by 3. Divide by 3. A is equal to 12. There you go. Wait! Oh, I hope you didn't move on, because you have to plug a back into HG. We want to find HG. So you need to plug that 12 in. You get 4 plus 2 times 12. Oh, yeah. 2 times 12 is what? 2 times 12 is what? What? 24. So we get 4 plus 24. And your answer is 28. You get 28 for the answer of HG. What do you think HK would be? Yeah, it'd be 28. 28 is equal to HK as well. Remember, come from the same exact external point, which was H here. And they are both tangents, because it says they are tangents. Both tangents, you set them equal to each other. Sweet! It was a very quick lesson, I think. I want you to try this one. You're going to pause now, do this on all by yourself, give it a shot, see what you come up with, and let's go through it. So pause, give it a shot. All right, so because FE and FG are tangent to circle F, not square, that is circle, we're going to find FG. So, how do I find FG? Very first piece of information, well, they both come from an external point, a point not on the circle, which is point F. Because of that, I take 2, 3 plus 6x is equal to 14x minus 8, and I set them equal to each other, because that's the theorem we know. So when I do that, I distribute this 2 through, I get 6 plus 12x is equal to 14x minus 8. I'm going to bring my 12x to my right side, because I like to deal with positive numbers. So I get 2x minus 8 on the right. I still have 6 on the left. Again, positive numbers, so I'm going to bring my 8 over to the other side. 6 plus 8 is 14. We now have 14 is equal to 2x. Even if you can do this in your head, I want you to be able to show your work, still go through those algebraic expressions and algebraic equations, so you get x is equal to 7. Wow, I used a lot of different colors on there, didn't I? Huh. Now we have to use x is equal to 7. What do we do with that? Plug it in, plug it in. Have you ever seen that commercial? Those commercials are good. Plug it in, plug it in. Anyways, okay, plug 7 into that x there. When you do that, okay, you now have 14 times 7 minus 8. Okay, 14 times 7 is 98. We're subtracting 8, and our answer is 90. So FG right in this situation is 90, because I found x by setting them equal to each other, because that's the theorems we know. From there, we have to take my x, plug it into my equation of the line, the tangent that I want to find. I want to find FG. I want to answer that question fully. Don't just find x. Make sure you're answering the questions that it wants you to answer. Answer the question it wants you to answer. Then, once I find that, plug it in for x, solve, and I get 90. Like I said, nice short lesson today. All done. Here's your assignment. I'm just kidding. I'll give you your assignment when you come back tomorrow. Have a wonderful day. I'll see you later. Ta-ta.